All right, number 2 on proving segment relationships practice. It says if xy plus 20 equals yw and xy plus 20 equals dt, then yw equals dt. So remember, when you have an if-then statement, you're trying to figure out how this if, your hypothesis, became this conclusion. And what has happened here is in the very beginning we established that xy plus 20 equals yw, and xy plus 20 also equals dt. Then in the next line we say then yw equals dt. So what's happened here is we established that these two quantities are equal. Yw is xy plus 20 and dt is xy plus 20. So here, instead of writing xy plus 20, since we established that xy plus 20 equals yw, we can establish that here, instead of xy plus 20, we can write yw equals dt. And what allows us to replace this xy plus 20 with this yw is the substitution property. Number 7, we have if jk plus mn equals jk plus qr, then mn equals qr. So what happens between our hypothesis and our conclusion? Well, the jk is missing from our conclusion, and the jk is missing from our conclusion here. So we have lost jk, or subtracted jk, from both sides of our equation, and we're left with mn equals qr here. So what allows us to do that is to subtract jk from both sides of the equation. That's the subtraction property. All right, number 10. You have JL is congruent to KM, and that is given to us, and we're trying to prove that JK here is congruent to LM here. So JL, that segment, is congruent to KM. This is what we're trying to prove. So first statement, JL is congruent to KM. Well, why is JL congruent to KM? Because it was given to us. From here to here, what has happened? Well, the JL doesn't have a segment bar anymore. The KM doesn't have a segment bar anymore. And the congruency symbol has turned into an equal symbol. And that is what allows us to do that is called the definition of congruent segments. It says that segments that are congruent are also equal. So what allows us to do that is the definition of congruent segments. All right. Next sentence, or next line, isn't going to be a from here to here type of one, because this set of statements is going to have to deal with our picture. And it says that jk plus kl equals jl. Well, jk is here, plus kl is here, and we're saying that equals the whole thing, jl. Well, all we're doing here is we're doing the segment addition postulate, where segment plus segment equals the whole segment. And then we are told that KL plus LM equals KM. So KL here plus LM here equals the whole thing, KM. Well, that's called segment addition. Two parts of a segment equal the whole length of the segment, segment addition. All right? From this line to this line, once again, it's not going to be linear. You're not going to be able to go from one step to the other. You have to look at the whole picture. So let's see what's happened here. Part of this line is that JK plus KL, that appears here. The other part of this line says that KL plus LM, and that appears here. And then we kind of cut out the middle guys here, and we say that JK plus KL equals KL plus LM. Well, what allows us to do that is the fact that we established in the beginning that JL and KM are equal to each other. And if JL and KM are equal to each other, then technically I can replace this with JL, right? And because JL and JL are the same thing, and I can take this JL here and replace it with what we said JL equals, which is JK plus KL. So I have substituted in this value and this value because they equal each other. So I substituted the JL for JK plus KL, and I substituted the KM with KL plus LM. That's the substitution property. All right, and then finally we have JK equals LM. Well, in this line we had JK plus KL equals KL plus LM. And if you notice, the KL and the KL from both sides of that equation just disappear. And what allows us to do that is if we subtract KL from both sides of our equation, they equal 0. And then we'll be left with JK equals LM. And then finally, from this line to this line, JK equals LM. We put a segment bar over JK, change the equal sign to a congruent sign, and we change the LM so that it has a segment bar. Oh, this should say LM. So this equal sign turning into a congruent sign is the definition of congruent segments. That says that segments whose measures are equal are also congruent. Okay, let's take a look at number 3. Since you have a test coming up, it's going to be a good idea to do all of the problems, even if they don't have to do with proofs. Number 3, you've seen this problem before. It's making its grand appearance. If you didn't get it the first couple times we went over it, here it is again. If GK bisects angle FGH, so let's start by drawing an angle FGH. And let's go ahead and bisect it by GK. So it's got to start here at G and go all the way to K. And because we are bisecting an angle, I'm going to mark this arc congruent to this arc. And then now I'm going to fill in my angle measures. The measure of angle FGK is 5W plus 8. Well, here's FGK. I'm going to mark it 5W plus 8. And the measure of FGH, F to G to H, this whole angle, is equal to 101. We're going to find W. Well, here's a hint. This little angle here, FGK, could not possibly equal FGH, the big angle FGH. So don't set 5W plus 8 equal to 101. If you recall, we were told that GK was an angle bisector. An angle bisector cuts the angle into two congruent angles. So 5W plus 8 is angle FGK, then angle KGH is also 5W plus 8. So angle addition says little angle FGK plus little angle KGH equals the big angle FGH. And now you just plug in the values that were given to us. 5W plus 8, I'm going to come down here. 5W plus 8 is FGK, so KGH is also 5W plus 8. And all of that equals FGH, which we were told FGH is 101. So we're going to take our like terms, 10W, our other like terms, 8 and 8 gives us 16, and that equals 101. I'm going to subtract 16 from both sides. That equals 85. So that's 10W equals 85. We will divide by 10, and W equals 8.5. Now we found W. Let's just go back at our problem and look to see if it wants anything more than W. And nope, it just wanted us to find W. All right, let's do some review. If a draw a conclusion given the following sets of statements and tell whether law of syllogism or law of detachment was used. If a student is having difficulty in class, that's P. Then that student's teacher is concerned, that's Q. Walt is having difficulty in science class. Well, if he's in science class, then he's a student having difficulty in class. So that's P. So far we have the conditional if-then, PQ. We're given another thought about P, that Walt is having difficulty in science class. Therefore, we are allowed to conclude Q by the law of detachment. And you actually have to write in the conclusion, and that's Q, but we need to make it personal to Walt. So if a student's having difficulty in class, the student's teacher is concerned. Q was that the student's teacher is concerned. So Walt's teacher is concerned about him.